Think of it as a super smart equation that takes data, churns through it, and spits out predictions, which we call inferencing. And the process to get there, that is called training. We train the model. Hello everyone. If you have ever wondered how your phone seems to know exactly what you're looking for, or how cars are learning to drive themselves, you're at the right place. Today we are going to explore how artificial intelligence is not just a buzzword, but a real part of our lives, improving the way we work, play, and connect with each other. Today we are diving deep into the core components of AI. So what are the methodologies that we will look into? Machine learning, deep learning, natural language processing, computer vision, and robotics. Let's start with machine learning. Have you ever wondered how Netflix recommends the perfect shows? Or how your email knows what is spam? The answer is smarter than you think, and it is called machine learning. It all starts with a simple idea. Can we predict the future based on the past experiences? Sounds like magic, right? But in fact, it's all about data and patterns. Let me explain it to you with an example. Let us say your friend runs an ice cream shop and has a smart app. This app looks at past sunny days to see how many ice creams were sold. It also checks if today will be sunny. If it is, the app suggests make a lot of ice creams today, so that your friend can have enough ice cream for everyone when it is sunny. Let me give you one more example. A doctor could predict a patient's risk of diabetes by feeding clinical data into a machine learning model. This isn't just saving time, it's saving lives. How exactly are machines learning and identifying these patterns? At the core of it, machine learning is a function. Think of it as a super smart equation that takes data, churns through it, and spits out predictions, which we call inferencing. And the process to get there, that is called training. We train the model. During training, we feed system loads of data. This data, or X, is full of features. That's the technical term for the information bits we care about. And the Y, that's the outcome we already know. Our goal is to teach the model to predict Y based on X. Once our model has learned the ropes, it's ready to make predictions on new data. That's where the magic happens. We input new features and our model predicts what the outcome will be, called Y hat. Let me give you a real-time example. Your music app always knows what songs you love. It's like it makes playlists just for you. This happens because of machine learning. The app watches what songs you enjoy, the beats, the singers, and when you like to listen. This info is the X. If you like a song, that is the Y. The app looks at lots of data about what songs people like and learns from your music style. So when there's new music, it guesses if you will like it or not. That's how machine learning gives your playlists that feel completely personal. Let me explain with another example. E-commerce product recommendations. When you shop online on Amazon or any e-commerce website and you buy a backpack, the website then shows you things like water bottles or camping gear. This is because of machine learning. The website looks at what you and others have shopped for before. That's what is the X. It learns what kinds of items usually get bought together. Next time you shop, it guesses what else you might like based on what it has learned, making your shopping experience completely personal and recommending you suggested items along with the product which you are buying. Let me solidify with one final example. Predictive texting in your messages. When you text and your phone guesses the next word, that is machine learning for you. Your texting app keeps track of words you often use together. That is the X. It remembers what word you usually type next. That is the Y. By learning from lots of text, not just yours, but maybe others too, the app gets good at predicting the next word you might type. That is the Y hack. This makes texting quicker and helps stop funny mistakes before they happen. Are you intrigued by machine learning as I am? And if you're hungry for more tech tidbits, make sure to hit the like button, subscribe, and ring the bell for notifications of our latest videos. Have you ever wondered how your phone knows what you're going to type next? Or how video games are getting smarter as you play? That's all thanks to something called as machine learning. Today we are going to take a closer look at machine learning. Machine learning can mainly be categorized into three distinct types: supervised learning, unsupervised learning, reinforcement learning. Let's dig deeper into what exactly is supervised learning. Imagine you have a smart computer but it does not know anything yet. You want to teach it to tell the difference between an apple and a banana. You show it lots of pictures of apples and bananas and you tell it which is which. Each time you show your computer a picture, you are like a teacher saying, this is an apple and this is a banana. After a while, your computer starts to notice things like, hey, apples are usually round and red, and bananas are long and yellow. The cool part is, after you teach it with enough pictures, your computer will see a new picture it has never seen before and guesses if it's an apple or a banana all by itself. That's the magic of supervised learning. Let me give you one more example to solidify this. We start our adventure by showing the computer lots of cats and dogs images. And here's the key. Each picture has a label that says if it's a cat or a dog. This helps our computer buddy learn and remember. After the computer sees more and more labeled pictures, it begins to notice patterns. Like cats usually have pointed ears and dogs have long noses. And guess what? Soon it can tell if a new picture is a cat or a dog all by itself. Now for the magic moment. We show the computer a brand new picture without telling it if it's a cat or a dog. Do you think it can guess it right? And it says cat. That's right. Thanks to all the labeling we did, it learned how to tell them apart. Amazing, right? That's machine learning for you. In the next video, we will break down supervised learning further into regression and classification. If you find this fascinating and are eager to discover more, make sure to hit the subscribe button. Join us as we dive deeper into the marvels of technology. Now that we have uncovered the secrets of supervised learning, let's zoom in onto the two superheroes, regression and classification. They sound fancy, but they are really about helping computers make sense of the world in two different ways. First up, regression. Imagine you are saving up your money to buy a new game. You might wonder, how much will I have in 6 months? Regression helps in predicting a number, like your future savings, based on the patterns from the past. For example, if you save $10 every week, regression can help you draw a line on a graph to predict how much money you will make at any point in the future. It's all about predicting amounts or numbers. Let me give you one more example of regression. Imagine you're playing a game where you can design and build houses. Now you want to sell the house and wonder, how much can I sell my house for? With regression, you can predict the selling price of the house on features like its size, the number of rooms, and even its location. By looking at past data on house sales, regression helps us draw a line that predicts your house price. So, if you have a house of 3 bedrooms in the city, regression tells you a number, say $300,000 or 1.5 crore rupees. It essentially is a tool to predict numbers as an outcome. Now let me talk about classification. This one's like sorting your toys into two different bins. Let's say we have pictures of pets and we want the computer to sort them into groups: cats, dogs, birds. Classification looks at each picture and decides which group it belongs to based on what it has learned. So if you show it a picture of a parrot, it knows to put it in the bird box. Then you show it a picture of a cat, it knows it should put it in the cat box. It's all about putting things into categories. Another example for classification: sorting emails. You know how some emails go straight to your spam folder? That's classification at work. Your email service learns from tons of emails. It looks at words and patterns that usually mean an email is a spam. Like if the subject line says, "You've won $1 million," then classification pitches in and it decides inbox or spam. If the email resembles the typical structure of a spam email, it gets placed in the spam folders. The sorting mechanism categorizes emails based on its learned patterns and characteristics. So while regression is about predicting numbers like our house price, classification is about choosing categories like deciding if an email is a spam or not. Both are superpowers of the supervised learning, helping our computers make smart decisions every day. And there you have it, friends. The two main types of supervised learning that helps computers learn from data: regression and classification. Fascinating, right? The classification can further be divided into binary classification and multi-class classification. Let's look at it in our next video. Thank you. Welcome back to our Tech Exploration Zone. Today we are diving into the fascinating world of classification again, but with a twist. We are looking into two special categories of classification: binary and multi-class classification. Let's unravel these mysteries with some fun examples. Let me take an example of binary classification. Movie recommendation system. Think of it like deciding if you want to watch a movie or not. It's a simple yes or a no, a thumbs up or a thumbs down. Binary because it's all about two choices. Imagine you have an app that suggests movies. After you watch the movie, you either like it or you don't like it. By telling the app your choice, you're teaching it your taste. With enough yes or no data, the app gets really good at knowing what kind of movies you will probably give a thumbs up to and recommend those movies to you. It's binary classification at work, making your movie nights better. Let's make it understandable with one more example. App notification settings. Imagine you have downloaded a new app on your phone. It asks if you want to receive notifications. A simple yes or no question. This is a classic case of binary classification. The app uses your choice to either send you updates or keep quiet. Based on just two options, it's like a digital on or off switch for your app notifications. Let me give you one more example. Online security check. Consider the scenario where you are logging into a banking website. The site must determine, is this person authentic? It's a binary decision once more. By verifying your password, it employs binary classification to grant or deny access to you. Much like a key opening a lock, your password grants access to your account. Now let's amp up the fun with multi-class classification. This time, it's not about two options, it's about several options. Let us understand it with an example. Let us think about an animal photo sorting game. Imagine you're playing a game where you sort photos of animals into categories: cats, dogs, birds, fish, and so on. Each time you drag a photo into its box, you're helping the game learn and classify animals on its own. Cats go with cats, dogs go with dogs. The game uses multi-class classification to understand and organize wide variety of animal types. It's like a digital zookeeper, sorting animals into their right spots. Let me give you one more example of classification. Social media reaction buttons. On social media, when you react to a post, you're not just liking it, you might love it, find it funny, surprising, sad, and even annoying. Each reaction you choose teaches the platform about what content engages you the most. This variety of reactions is a perfect example of multi-class classification. Let me give you one more example. Voice assistant commands. Consider talking to voice assistant like Siri or Alexa. When you say commands like play music, set an alarm, check the weather, or turn on the lights, the assistant has to figure out which category your command falls into. That's multi-class classification, working to understand and assist you better every day. So remember, whether it's choosing movies or answering life's big questions, binary classification is everywhere. Just make sure you're ready for the results of your choices. If you didn't subscribe yet, do subscribe for more fun and tech knowledge. There are 3 types of machine learning formats: supervised learning, unsupervised learning, reinforcement learning. This video is about understanding unsupervised learning. If you landed on this video first without learning about supervised learning, click on the link above to learn about supervised learning. Let's move on. What is unsupervised learning? A realm of machine learning where algorithms learn patterns and insights from data all on their own, without us telling them what to look for. Imagine receiving a box filled with puzzle pieces, all mixed up, but with no guide to the final picture. Your task is to organize them and discover what image they form. It sifts through data, uncovering patterns and clusters without relying on pre-existing labels or instructions. In supervised learning, if you remember, it's all about labeling the data. Here, we don't label the data. The machine learns by itself. This fascinating world mainly consists of 2 types: clustering and dimensionality reduction. What is clustering? Let's understand with a movie streaming service. Think about Netflix. With vast library of movies to choose from, the aim is to suggest films based on what users like. By using clustering, the platform organizes movies into categories like action, romance, horror, or documentaries. It's like finding people in a big group who enjoy the same things as you do. Let me give you one more example of clustering. Your photo app automatically organizes pictures into albums such as beach holidays, family gatherings, or mountain hikes based on the content in the photos. The app identifies these themes independently, making it easier for you to relive those memories. It's truly fascinating, isn't it? Now, what on earth is dimensionality reduction? Let me explain the same with an example. Customer feedback analysis. Say a company like Apple collects massive amount of feedback from customers. With such vast volume of customer feedback, dimensionality reduction serves as a smart filter. Instead of sifting through every single comment, this method categorizes feedback into main themes such as product quality, customer service, and delivery times. By simplifying the data to these core areas, Apple can understand what customers truly care about. For example, when many comments focus on product quality, dimensionality reduction sees it as important. This helps Apple quickly spot what they are doing well and where they can improve. It makes decisions easier and keeps customers happy without getting lost in too much of detail. Let me give you one more example. News article summarization. Think about a news app that gives you short summaries of the most important stories each day. With so much of information out there, dimensionality reduction helps pick out the key points, keeping you updated without feeling overwhelmed. It's like having your own editor highlighting the most important stuff for you. So, unsupervised learning through clustering and dimensionality reduction helps you make sense of the chaos, uncovering hidden patterns and simplifying complexity. Intrigued by how algorithms can uncover the invisible threads that connect our digital world? There's so much more to discover together. Hit the subscribe button and let's continue unraveling the mysteries of machine learning. Today, we are venturing into the captivating world of reinforcement learning, a unique corner of machine learning where computers learn much like we do, through trial and error and a system of rewards and consequences. There are three types of machine learning formats: supervised learning, unsupervised learning, reinforcement learning. This video is about understanding reinforcement learning. If you have landed on this video first without learning about supervised learning and unsupervised learning, click on the link above to learn about the other machine learning models. Now, what is the concept of reinforcement learning? Imagine playing a video game where you control a character exploring a maze. Your goal? To find the treasure without being caught by the guards. In reinforcement learning, the computer plays this game over and over, learning from each attempt. Now, how does this character learn? Each time the character makes a move, it receives feedback. A step closer to the treasure, it increases the score, a reward. Getting caught, the score decreases, a penalty. The computer uses this feedback to learn the best strategy to achieve its goal. So we train the computer using rewards and penalties. Interesting, right? Let me give you one more familiar example. A self-driving car. Now let's take it to the streets with a self-driving car. The car's goal is to reach its destination safely and quickly. It must decide speed up, slow down, turn, or stop, all while obeying traffic laws and avoiding obstacles. Just like our game character, the car learns through experience. A smooth, quick ride earns a reward, while a near miss or a traffic violation results in a penalty. Over time, the car gets better at making decisions, learning the optimal way to drive in any situation. The beauty of reinforcement learning lies in its process of learning. The agent, be it a video game character or a self-driving car, adjusts its strategy based on the outcomes of its actions. It's a continuous loop of trying, learning, and improving. Through reinforcement learning, machines can master complex tasks, from playing chess at grandmaster level to optimizing energy consumption in large buildings. It's all about making smart decisions, learning from the environment, and aiming the best possible outcome. If you are fascinated by how technology learns and grows, make sure to hit the subscribe button for more insights into the AI revolution. Until next time, keep learning, keep exploring. Next up, learn the basic terminology of machine learning. Whether you are a budding tech enthusiast or just curious about how machines learn, you're at the right place. Let's decode the basics together. Let's understand the basic terminologies of machine learning. Features, labels, training, model, inference. What are features? Think of features as the ingredients in your favorite dish. In machine learning, features are the specific details or characteristics that help us describe each piece of data. For example, if our machine is learning about fruits, features might include color, shape, and size. These features help the machine distinguish an apple from an orange. Labels. Continuing with our fruit example, labels are like name tags on each fruit. In machine learning, a label is the answer or outcome we are trying to predict based on the features. It's what we are teaching the machine to recognize. So if we show our machine a bunch of fruits and tell it which ones are apples, apple becomes the label for those examples. Training. This is where the magic starts. Training is like teaching your pet a new trick, but instead, we are teaching a computer to make predictions. We do this by feeding it lots of examples that have both features and labels. Our fruit identifying machine gets to see lots of different fruits and learn which labels match which features. Model. After all the training, what we get is the model, the core to all the machine learning. You can think of model as a brain that's been filled with knowledge. It's a set of rules or patterns that machine has learned from the training data. Now our machine has a model or a guide to help it identify fruits even when it sees new ones it never encountered before. Finally, we have inference. After our machine has been trained and has its model, it's ready to make predictions on new data. When we show it a fruit it hasn't seen before, it uses its model to infer or guess the label of the fruit on what it has learned. That's inference. Using the learned model to make predictions. And there you have it. The building blocks of machine learning. From understanding the details with features to making smart guesses with inference. You are now equipped with the knowledge to start exploring this fascinating field of machine learning. If you are eager to learn and dive deeper into the world of technology, hit the subscribe button. Let's embark on this journey together. Thank you. See you in the next video.